from the book. Like I kind of did this at the top of the problem page. And these are the different patterns that we need to be looking for. Let me get my color here. And so what we have is the graph I'm talking about right here. This is the one where if we want to write an equation for it, we're going to have to use what we call vertex form. And vertex form is y equals a x minus h squared plus b. So that's the vertex form. The normal form that we're going to use for these others, where we can actually see where they cross the x-axis, where primarily we can use vertex form if we wanted to, but the easiest way is to do like x minus, let's see what we call that, x minus some numbers. Times x minus another number. Where n1 and n2 are the roots. And that's the other form that we're going to have for these. So this one would come from a perfect square trinomial. Like if we said that, let's say this hits the x-axis at a -2. Let me change colors over here. So if this hits at a -2, then we would have x plus 2 times x plus 2. So remember, it's always the opposite of the coordinates of the point. So a -2 goes in as a +2. So that would be the equation of that one. If we had one like this one up here, let's say this is at a -3, and let's say this is at a +2, then this one would be y equals x plus 3 times x minus 2. And that's how we would write that one. So if you have the roots, it's easy to write the equation. If you happen to have one that just touches at one point, that's going to be the one that has, you know, x plus 2 squared. You know, it's going to have the same thing times the same thing. Let me turn the volume down here a little bit. Okay, any questions on that? Does anybody have any questions at all? If you do, like, shout it out or put it in the chat and let me know. Now, the other thing we can talk about while we're on this diagram here is, let me get a different color up. I'll use a little bit different thickness here. Let's see. So, in terms of the discriminant, like if you have to do the quadratic formula, you have b squared minus 4ac as the discriminant. So if you can't factor it any other way and you have to use the quadratic formula, then you should always do the discriminant or the square root part first, because if it's not factorable, then you'll find out right away. And that kind of boils down into like 3 cases. You could get a positive number inside the discriminant. If you get a positive number inside the discriminant, that means you have 2 roots. So it's going to be one like this first one up here. So I'll call this A. So you've got 2 roots. It's going to be like A. If you get a 0 inside the discriminant, like everything cancels out, and you have a 0 inside there, then it's going to be like type B, which is the middle one. You're just going to have a double root. What we call a double root, it's basically, it touches the x-axis at one place, but it's a double root. It's really -2 and -2 in there. And, but you just, you know, it's just really x plus 2 squared equals x plus 2 squared. Those 2 quantity squares. That's another way that we'll see one of those written. And if you get a negative inside, then it's type C. So if all this boils down to a negative number, and you got to be really careful with the minus 4ac times everything and put everything in and make sure that, negative 4 times the negative is going to be a positive. This is an easy place to mess up with your numbers. But if you get a negative inside there, then you can't use the quadratic formula to find the factors because there aren't any. It's like type C. You're actually, with the quadratic formula, finding the places where it hits the x-axis. And this one, like type C, floats up above the x-axis. So it doesn't have what we call any real roots. There's no place where it crosses the x-axis. And this is the one where if we need to do an equation of it, we're going to have to use a little bit of a different method called the vertex form. And what we're going to do is we're going to take the coordinates of the vertex, which are this should really be a k probably. That's the h and the k that goes with the coordinates of the vertex. And then we need another point that's actually on the graph that we can read from the graph, like say a point there. And we would put that in for our x and for our y, just like we were, solving like a linear equation with a slope or something like that. And from that, with these other numbers put in, we can figure out what the a is. And then that's going to be how wide or how narrow the graph is. So we've got to go through that process and find the a, and to be able to come up with the equation. So that's what's a little bit different. So let's look at the next page here and see what we have. Use the mouse. So again, if you have any questions on it, let me know. Okay, I see somebody else just logged on just recently. Put your name in the chat so I know that you're here. So so this is the 4-2 problems. Number 1 says, write a short paragraph explaining how to solve t squared minus 6t minus 4 equals 0 by completing the square. So the main idea with completing the square is you want to just have t's on the left side and all your numbers need to be gotten on the right side. Then you're going to, the other thing is you can't have another number out in front of the t squared other than a 1. If there is, you got to divide it out. So that's the first step, is to make sure you only have a 1 coefficient in front of the t squared term and all your numbers are on the right side. Then you're going to take half the middle. So I'm going to talk through it first and we'll do it. Then you're going to take half the middle term, which on this one is the negative 6, which half of that's going to be a negative 3. I'm going to square the negative 3, and that gives me a 9, and I'm going to put a 9 on each side then. And by doing that, the one on the left is going to be in what we call perfect square trinomial form, and that's going to factor into x minus 3 times x minus 3. But what we're going to do then is take the square root of both sides, so we're going to have x minus 3 on one side, and the square root of whatever numbers are on the other side. And then when we move the one number part over, we'll have the equation. So that's what we're going to do with this. So, so for number 1, let me go down here. For number 1, let me start with a t squared minus 6t minus 4. So the first step is to move this minus 4 to the other side by adding 4 to both sides. So we have t squared minus 6t equals 4. So move negative 4 to other side. So this might actually not be a paragraph. This might just be like a couple of sentences. So you move the negative 4 to the other side. Next step, you're going to take half of this and square it. So half of this is going to be a negative 3. So negative 6 divided by 2 equals negative 3. Negative 3 squared equals 9. Let me switch colors here. And what we're going to do then is put 9 in here and 9 over here to keep the balance. That's the trick. So take half, middle term, coefficient, and square it. add to both sides. So that's step 2. So now we're looking at this. So we can see on the right side we've got a 13. We'll go back to blue. So on the right side we've got now, or on the left side we've got t squared minus 6t plus 9 equals 13. Now, by doing this process here in this step 2, we made this into a perfect square trinomial. It's got a perfect square on this end, t times t, perfect square on this end, which happens to be either 3 times 3 or negative 3 times 3. It's actually negative 3 because of the middle being a negative. And it's got twice the product of those factors in the middle. So if this factor is a t, this factor is a negative 3. Negative 3 times t is negative 3t. Twice that is in the middle. That's the pattern that we check for to see if we have a perfect square trinomial. That means this is going to factor into t minus 3 squared, or t minus 3 times t minus 3. And on the other side, we still have the 13. Now we're going to take the square root of both sides. And when we do that, we're going to get rid of the square on the one side. And we're going to end up with t minus 3 equals plus and minus the square root of 13. And this is where our two roots are going to come from. We're going to add 3 to both sides then, and we're going to have like 3 plus square root of 13, 3 minus square root of 13 as the two roots that go with the equation. Okay, so let's see. So step 3, what we're doing is take square root of both sides. I'll use the abbreviation SQRT, square root of both sides. And simplify. So let's see, to finish up then. Now, register perfect explained by the completing the square. Okay, so our answer is going to be, when we add 3 to both sides, we're going to have t is equal to 3 plus square root of 13, or 3 minus square root of 13. Now, the square root of 13 is between 3 and 4. Like 4 times 4 is 16. 3 times 3 is 9. 9 is 4 away from 13. 16 is only 3 away from 13. So it's going to be a little bit more than 3.5. So I would guess maybe 3.6 as the square root of 13 if I didn't have a calculator. So this is going to approximately be 3 plus 3.6, which is 6.6, and 3 minus 3.6, which is going to be 2.4. So those are going to be the approximate roots of the equation. And we've solved it. Like when they say solve, they mean find the roots. So if this was a problem where you did the quadratic formula and there was no solution because you had a 0, then there would be no solution. But solve means find the roots. So they're using t's instead of x's. Doesn't really matter. But this is going to cross the x-axis as 6.6 and 2.4. And then halfway in between is going to be the vertex if we needed to do the graph and everything like that. Okay, let's look at number 2. Let me see if I can get some more space here. Let me hide this. Let's see if I can extend page. I don't see that I can extend page. So I'm going to insert page here. So if we go back to this, it says, discuss what method of solving 5p squared minus 13p plus 7 would be most appropriate. So we got 5p squared minus 13p plus 7. pick the ink. So you got 5p squared plus 13p. So let's discuss what method would be the most appropriate. So if I wanted, so like this goes back to our hierarchy thing, like is there a common factor? Okay, I don't see a common factor I can take out of these. Say, so knock that one off. Is it a perfect square trinomial? No, it's not. That's not a perfect square. Is it a difference of two squares? No, it's not. There's three parts, and there's no minus sign in the middle, so it's not a perfect square trinomial. Can I guess and check it? I don't see that it's guessable and checkable. Now, this is where we could either go on and do the completing the square. Now, the completing the square, we're going to be taking half of 13 and squaring it, which is going to be like 169 over 4. So that might be a mess with a bunch of fractions. It'll work, but it might not be the easiest way. Quadratic formula, minus 13 plus or minus the square root of 13 squared minus 4 times 5 times 7 over 10. That would be doable. But I want to try to factor it by using the method that comes after the guess and check, which is the bomb method, to see if I can figure out that it can be factored. And if that doesn't work, then I might have to go on and use the quadratic formula. So the bomb method is to multiply these two outside numbers together. So I've got a 35p squared. And I take the middle term, which is 13p. So this is instead of doing the box method. So what I want to do is find two numbers that multiply to be 35, that multiply to be a positive 35, and add up to be a positive 13. So with 35, we've got 1 and 35, we've got 5 and 7, and that's it. I don't see any other, there's no other factors that make 35. So we can't really come up with factors. We've got 1 and 35 to choose from, and we've got 3 doesn't work, 4 doesn't work, 5 works, 5 times 7 works. And once you're up to past the square root, which would be 6, you don't really have any more factors. And none of these have a possibility of coming out to be 13. So this, you can't do it with this method. So that means we have to use the quadratic formula. So I kind of went through a hierarchy or a list of things. The easiest thing to do is common factor. If so, take it out and then see if that simplifies it. Second step, special pattern. That's perfect square trinomial or difference of two squares. Third step, guess and check. Now, guess and check works really well if you don't have a number in front of the squared term. You're just looking for numbers that multiply to be the third number, and add up to be the middle number. So those are pretty easy to do if they're going to work out. Fourth is try the bomb method. If guess and check doesn't work, try what I call the bomb method, which is the one I just talked about. And if that doesn't work, now if you can find factors with the bomb method, it's going to work, and that's the way to finish it. And we'll look at some of those coming up. Then you have to do quadratic formula or completing the square. They're both kind of the same. Or complete the square. Complete the square if you've got numbers that are like this 13 over 2 squared is going to be 169 over 4. That I think makes it more complicated, but it is doable that way. And in fact, the quadratic formula is really just a general case of completing the square anyway. Now, so let me go back to this and see if we actually had to do it. It just says discuss which method would be the most appropriate. Okay, explain, then solve. So we still have to do the solving of it. So we're going to do the quadratic formula. So you need to memorize the quadratic formula. You know, sing it if you have to. to the tune of pop goes the weasel, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's the way you remember it. Back in the day, we used to have classes go around singing it for the other classes. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So what we have to do is find our a's and our b's and our c's. A is equal to 5. Now, instead of talking about this, like, legit, I would have gone ahead and just jumped. I would have seen, okay, it's not going to be any of these others. I would just tried the bomb method and then done quadratic formula. But we need to talk through this because we need to kind of see the rationale behind the different steps. And some are going to be easier for some numbers combinations than others. So those are our a's and our b's and our c's, and all we have to do is plug it in. So x is equal to minus b, which is minus 13, plus or minus the square root of 13 squared, which is 169, minus 4 times a, which is 5, times c, which is 7. Now this is where you got to be careful. If you've got negatives involved with the b's and the c's, you got to be careful when you're doing the minus 4 times everything to make sure that the sign comes out right, because that's going to give you the thing about whether or not it's doable or not. So 5 times 7 is 35. 4 times 35 is twice 2 times 35, which is twice 70, which is 140. So we have 162 take away 140, which is going to give us 22. So I did a lot of stuff there in my head, which might lead to a wrong answer, but basically got that. And so we got minus 13 plus or minus the square root of that over 2a. I left the 2a part out of the one above it. And 2 times a is going to be 10. So x is equal to minus 13 plus the square root of 22 divided by 10. And x is equal to minus 13 minus the square root of 22 over 10. Now, square root of 22, 5 times 5 is 25, so 22 is 3 away from it. 4 times 4 is 16, and that's 6 away from it. So it's going to be closer to 5 than it is to 4 for the square root, so you might guess 4.7, something like that. So if you did like minus 13 plus 4.7, you'd have a negative 8.3 over 10. And then the other answer would be negative 13 minus 3.6, or no, 4.6, which is going to be 17.6 over 10. And it's going to be a negative. And those would be the two solutions. So at negative 0.83 and negative 1.76, this is where the graph would go through the x-axis if we needed to actually kind of go with the graph that does that. Okay, so in terms of factors, I guess we could say, x plus 8.3 over 10 times x plus 1.76 over 10 would be the factorization of it. But we usually don't need to do that. Okay, questions on that? So for this problem, they wanted us to discuss which method would be most appropriate, explain, then solve. So the most appropriate method as you work through this hierarchy seems to be like, it looked like the bomb method might have a chance of working, but the numbers weren't right. So it was basically had to do the quadratic formula. And I should have actually done the discriminant part first, because if this turned out to be a negative number inside here, I would have known right away that there was no solution, and I wouldn't have had to bother with any of this other stuff. But this did come out to be a positive number, which means there are two solutions, and we can see that we did get two solutions on that. Okay, let's look at the next set now. So number 3, describe the discriminant of the equation represented by each graph. So this is what I kind of went over on the first page. If you have the pattern where this comes down and just hits the x-axis at one place, that's a perfect square trinomial pattern. That's going to actually be x plus n squared y equals. But in terms of the discriminant, when we try to do the quadratic formula to find that, this is the one where we get a 0 when we simplify the b squared minus 4ac part. Now this one over here is the one where you can't actually, this would be not factorable with the quadratic formula, and you would find out as soon as you did the discriminant part that you would have a negative result inside there once you simplified the b squared minus 4ac. That means it doesn't have any real factors. But we could still come up with an equation for this one by knowing the equation of that vertex and one other point that's on the graph, and then we would have to use vertex form to come up with the equation. And we'll do some of those, hopefully. And this last one is a more normal case. Now it happens to be upside down, but the thing is, there are the roots. So this is like going to be the x minus n sub 1 times x minus n sub 2, whatever they are. Well, this one's going to be minus, this one's going to be plus. So n sub 2, n sub 1, and y equals. But in terms of the discriminant, this is the one that's going to give us a plus, a positive, when we do the b squared minus 4ac part. So if you do the discriminant part and you're doing the quadratic formula, if you get a positive number once you simplify it, you can move on. There's going to be two answers. If you get a negative inside, there's no answer at all. It cannot be done. And if you get a 0 inside, you should expect this double root idea. You're just going to get one number, but it's actually a double root because it's x plus something times the same thing squared. Okay, math journal. Solve x squared plus 4x minus 5 equals 0 using each of the 4 methods described in this lesson. Which method do you prefer? So this is going to be work because there's 4 parts to it. But this, if you can do this, you're set for these. The only way you can mess up would be maybe with some more complicated numbers. So what we have going on here is, okay, we want to do it with the guess and check method first. So remember the order of operations. There is no common factor. So I'm just going to take the x squared plus 4x minus 5 equals 0. And what I'm doing is I'm looking for numbers that multiply to be a negative 5 that add up to be a positive 4. And so the positive, now you can either have 2 negatives that make a positive, or a negative and a positive. So you kind of have to think about sign differences. So what makes a 5 is a 1 and a 5. And I can see where with the 1 and the 5, I could get a difference of 4 out of that. Now I need to make sure this comes out to be a positive 4. One of these has to be negative because they need to multiply to be negative 5. So the negative sign needs to be with the 1 on this one. Now if there had been a negative 4 in the center, the negative sign would be with the 5 and the positive sign would be with the 1 because that would still give us the negative 5. But when we add them, we would end up with the sign that we needed. But we need a positive 4, so the bigger one needs to be positive, the other one's negative. And we got the answer then. That's going to be an x minus 1 times x plus 4. Which means x is going to be 1 and x is going to be negative 4. For the solution for this one. So that's the guess and check method. That's what I call the guess and check method. Okay, method 2. I guess completing the square. And then we'll do quadratic formula also. And what other method do we got then? Completing the square. Well, let's do completing the square, and we'll see if there's another one. I think there's really 3 main methods. So I do x plus 4x, but instead of having the negative 5 where it's originally at, I add 5 to both sides, so it moves to the other side of the equals and becomes a plus 5. So I added 5 to both sides. Now we want to complete the square. We want to take half of this and square it. Half of 4 is 2. 2 squared is 4. So I'm going to put a 4 in there. And I need to put a 4 on the other side also. Now this is going to factor into x plus 2 quantity squared equals 9. Take the square root of both sides. X plus 2 equals the square root of 9, which is 3. So SQRT both sides. And take 2 away from, we have plus and minus 3. Don't forget the plus minus. So x is going to be equal to 3 take away 2 or negative 3 take away 2 when I subtract 2 from both sides. So 3 take away 2 is going to give me a 1. And negative 3 take away 2 is going to give me a negative 5. So did I mess up over here? This should have been a 5. So notice I didn't know that I made a mistake here until I tried to do it another way. That's just another thing on the test. If you have time, whenever possible, you should maybe go back and try it a different way to verify. But that should have been a negative 1 times a 5 there for that one. So that's how we would get the answer using the completing the square. Now, quadratic formula. We got our x squared plus 4x minus 5 equals 0. What we want to do now is find the a and the b and the c. So the a is a 1. There's no number there. It's a 1. The b is a 4. And the c is a 5. And we have x is equal to minus b minus 4 plus or minus the square root of b squared, which is 16, minus 4 times a, which is 1, times c, which is 5, all over 2a, all over 2. So that's what needs to be simplified. So inside the square root, inside the discriminant, we have 16 take away 20. Whoa, what's up with that? B squared, okay, minus b. So b squared minus 4ac minus b plus or minus the square root of b squared minus 4 times a times c over 2a. Kind of with a negative 4 inside there. So somewhere I'm making a stupid, oh, c is a negative 5. Okay. Now, notice if I just launched into doing this without having done these others, I wouldn't have even known that I made that mistake. So there's no real feedback on mistakes unless you're careful. This should have been a negative 5. So, and this, because this would have come out a negative, and I'm thinking like there are roots, so it can't be a negative inside the discriminant. Where was the mistake? And it was a negative 5. That was kind of hard to catch. But a negative 4 times a negative 5 is a positive 20, and that with the 16 gives me a 36. And the square root of 36 is 6. So we have negative 4 plus and minus 6 over 2 as our x equals. So I simplified a bunch of stuff at one time there. So negative 4 plus 6 is going to be a 2, and 2 over 2 is going to give me a 1. And then for the negative branch, a negative 4 take away 6 is a negative 10, and a negative 10 over 2 gives me the negative 5. So that's the way the quadratic formula would work to find that 1 and negative 5 are the answers. Now, which one's easier? I don't know. Like which, it's up to you. Sometimes one's going to be easier than another. I generally try to avoid fractions. The guess and check method, if the numbers are easy, is probably the easiest way to go. So I would probably prefer this one. just based on the numbers that are there. Completing the square is not much harder than that, but there is a little bit more work involved in it. And the quadratic formula isn't really that hard, but you've got to be careful because there's places where you can make mistakes with any of these. So there's not really a right answer for this, but you need to do these, even though I've done them, don't just copy it down. Actually think your way through these, because these are the ones that are going to help you out for later problems. And I really can't think of what the fourth method is right now. Those are the three main ones. There's like guess and check, complete the square. I guess the bomb method, but the bomb method is really just the guess and check if you have a 1 out in front. Difference of two, there's not a special pattern. So anyway, so let's change this to 3 or 4 methods of the 3 or 4 methods. And if you see a fourth method in the book, let me know, and I'll be sure I do that next class. Let's go on to the next set now. Solve each equation by completing the square. So I'm just going to kind of start out with this, move stuff over. I'm going to add 24 to both sides. So we got z squared minus 2z plus or minus some number equals positive 24. Now take half of this and square it. Half of a negative 2 is a negative 1. Negative 1 squared is going to be a plus 1. So I'm going to add 1 there also to keep the balance. If you add to one side, you got to add to the other side, same thing. This is going to factor into x minus 1 times x minus 1. And on the other side, we have 25. Take the square root of both sides. X plus 1 is equal to square root of 25, which is plus and minus 5. X is going to be 1 plus 5 and 1 minus 5. So we get 6 and we get negative 4 for the roots for that one. So that's the completing the square method. Completing the square for this other one, we're going to move the 88 over. Switch colors up. So for this one, we got p squared minus 3p equals 88. So we, plus 88 to both sides. Take half of negative 3, that's a negative 3 halves. When we square it, we get positive 9/4. So we add 9/4. And we add 9/4. Now the 3 halves, this is where it pays to remember what the original factor was. It was minus 3 halves. And that was squared. So this is going to factor into p minus 3 halves squared equals, and so you've got fourths going on here. So 4 times 88, 4 times 90 would be 360. 88's 2 away. So 360 take away 8 is 352. So we're going to have 352 over 4. So what I did here was 352 over 4 plus 9 over 4 gives us 361 over 4. So what I did here was I had to have common denominators. Start out over 1, I had to make it over 4, so I did times 4 and combine them together. Take the square root of both sides. P minus 3 halves equals 361 over 4. Add 3 halves to both sides. I'm going to add it as 6/4 to have common denominators. So P is equal to 6/4 plus 361 over 4 and 6/4 minus 361 over 4. So that's going to give us a 367 over 4. And this other one's going to give us a minus 355 over 4. And then we could go ahead and turn that into a decimal if you needed the decimal. But this is good. You could stop right here with these 2 answers for that one. Now for the third one, completing the square on that one. We're going to move the 21 over, and it's going to become a negative 21. So we're going to do 14 down here. And we got x squared minus 10x equals minus 21. Half of the middle is going to be a negative 5. Square that, it's going to be a plus 25. Plus 25 over here. This is going to factor into x minus 5 squared. And on this side, we're going to have 4. Take the square root of both sides. X minus 5 is equal to plus and minus 2. Always remember the plus and minus part when you're doing the square root. And you're going to add 5 to both sides. So x is equal to 5 plus 2 and 5 minus 2, which is going to give us 7 and 3 for the answers for that one. So completing the square is, if you got good numbers, completing the square is pretty straightforward. But then look, this is a perfect square trinomial. This is a 25, which is 5 times 5. This is an x. Right away, we can see it's going to be x minus 5 squared without doing any other work. Well, if we had, once we did that. Looking at it in the original form, though, it's not so well. In original form, guess and check would be 3 times 7 makes 21. So a negative 3 times a negative 7 is going to be a positive 21, and a negative 3 times a negative 7 is going to be the other. So if it was my choice on this, I would have just gone straight for x minus 3 times x minus 7 equals 0, which would have given me the 7 out of this one and the 3 out of this one. So I could have got it that way a lot easier in the second step of is it a guess and check type problem. Okay, questions on that? So this is, I know some of you probably haven't done a whole lot with these before, but this is really a review of a lot of stuff that was done in Algebra 2. Find the discriminant, describe the nature of the roots, then solve. Okay, so we're going to have enough time probably to find the discriminant and to be able to move on. We might have to come back and solve this when we have time to do it. But I'm just going to list my A's and my B's and my C's. My A is a 6, my B is a 7, and my C is a negative 3. For this one, my A is a 1, my B is a negative 5, and my C is a 9. So x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. So x is equal to minus b minus 7 plus or minus the square root of 49, which is b squared, minus 4 times 6 times negative 3. And I never try to do this part in my head because it's too easy to screw up with the negatives and everything. And all this is going to be over 2a over 12. So this part here, 4 times 6 is 24. 24 times 3 is 72. It's positive. So we have a 72 with a 49. 72 with a 50 would be 122, but one less than that is going to be 121. So we actually get square root of 121 in the numerator. So negative 7 plus or minus 11, which is the square root of 121, over 12. So we got minus 7 plus 11, which is going to be 6. No, it's going to be 4 over 12. And the minus side is going to give us minus 18 over 12. So this is going to be 2 goes into that twice. Well, 1/3, 4 goes into it once, and 12 3 times. And this one, 6 is going to go 3 times, and 12 twice. So we got positive 1/3, negative 3/2 for that one. So the discriminant. To the discriminant, it came out as a positive number. We're looking for 2 solutions. That's their point on this one. And we got 2 solutions. Over here, same thing. Minus b. Minus a minus 5 is a plus 5. Minus b plus or minus the square root of b squared, which is going to be 25, minus 4 times 1 times 9 over, well, just the discriminant part. It's all going to be over 2a over 2 times 1. But if we do this discriminant part here, we have 25 take away 36, which is going to be a negative 11. So this square root here gives us a negative 11. There's no real solutions. You can't finish with the quadratic formula. Picture-wise, that means that this graph is going to be floating up in one of the, it's going to be floating up above the x-axis. There is no real solution because it doesn't cross. This one over here, if we need to sketch the graph, this is going to cross at 1/3 and negative 3/2. So we know it's going to look like that. But this one, no real solutions. It isn't that the graph doesn't exist. It just doesn't cross the x-axis. That's 20 and 21. 23 and no, this one's going to be a mess. What I would do with this one first is, okay, find the discriminant, describe the nature and the roots. Okay, so we got minus b, we got 84, plus or minus the square root of b squared, which is minus 84 squared, minus 4 times 36 times 49. So this is going to be a mess inside here with the discriminant. Now let's look and see what we get. So this is going to be like 80 times 80 is like 6,400. 50 times 36 is going to be 1,800. 1,800 times 4 is like 7,200. It looks to me as though this might come out to be a negative with no solutions. I don't know. Like, you got to do this on the calculator. I would have looked at this one as, is it a perfect square trinomial? The factor of this one is 6d. If we were just doing this straight out, and this is a 7, and 6 times 7 is 42. Twice 42 is in the middle. This is going to be 6d plus 7, or no, 6d minus 7 squared equals 0. So really easy if you recognize that you have a perfect square trinomial. Otherwise, look at all the big mess you got to go through with the numbers. So they wanted us for this section to evaluate the discriminant. This does have a solution. So this must come out to be a positive inside there, because there are going to be two solutions because it can be factored. But I'll leave it to you to try to work out those numbers. So when you do this, you actually have to work this out and show that it is a positive. You should expect two solutions and then finish the quadratic formula. Same thing. Now let's look at this one. This is a 2x, and this is a 3. 2x times 3 is 6x. There is not twice 6x in the middle. This is not a perfect square trinomial. This is one where you would probably just end up having to use quadratic formula anyway. So we have minus b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times 4 times 9, all over 2a, over 8. Looking at the square root part, we've got 4 take away 16 times 9, which is like 144. So we're going to end up with a negative 140 there. This one cannot be done. There's no real solutions because of the negative inside the discriminant. So this goes back to what we talked about at the very beginning. Okay, conjugate. The conjugate, you want to multiply by something that's going to cancel everything out, or you want to cancel out the I part. So the conjugate of this is going to be the negative 7 plus I root 5. And notice what it looks, this is sort of like a perfect square trinomial type thing, or notice the difference of two squares thing. Let's look at negative 7 minus I root 5 times that. So if we FOIL this, we have negative 7 times negative 7, which is 49. We've got a negative I root 5 times a negative 7, which is going to be a positive 7 root 5. But then with the other one, we have a negative 7 times I root 5, which is going to be a negative 7 root 5. Those are going to cancel each other out, and the negative I times negative I is going to give us a negative I squared as we do the third part of the FOIL. And the root 5 times root 5 is going to give us a 5. And I squared is defined as a negative 1. So the square root of I squared is a -1. No, the square root of a -1 is I. The square root of a -1 is where I comes from. So when you square I, you get a -1. These are complex numbers. We just call them imaginary numbers. So you basically have a +1 with a -1 here that you get from the I squared, which is a +1 times 5. So we have 49 plus 5, which is 54. So that actually turns into a 54. So this is what the conjugate is all about when you're trying to simplify. Like, let's say this is in the denominator of a fraction. You want to get this into some kind of a number. This could actually turn into 1/54 because of the conjugate thing. The conjugate of this one is going to be 5 plus 2i. So it's always what's going to cancel this other one out. So 5 plus 2i. And that's the conjugate of that one. And you can see when you multiply them, you're going to end up with the difference of two squares, and it's going to work out. Okay, so that's all we have time for today. I see a couple more people logged on since I took attendance. Let me see. Make sure you get credit. Okay, I got Jose, Ruben, and Ryan. Okay, so you guys are all here. So I will save this, and I will see you guys on Friday then. And in the meantime, I'm going to turn this into a YouTube video, and I'll post the link on the problem page that goes with 4.2, so you can come back and replay this as you need to. Okay, so I'll see you guys. Let me know if you have any questions on anything.